3 different types of transformations, maybe. So let's get a definition down for what a transformation is first and foremost. So your transformation is an operation that moves or changes a geometric figure. So after the figure has been moved or changed, we come up with what's called the image. And the image is the new figure after the transformation. And I do want you to make notice, we use a specific notation. Like if I were talking about point A, when I were to transform it, you're going to see a little symbol like a prime symbol that tells you what the image is. So it looks like an apostrophe in English class. In math class, we call it a prime symbol. When you see that, that means that that shape is the image. So you'll have a shape, and then you'll have a second shape that will have prime symbols at the coordinates, at the vertices, and then that's how you will know which one is the image as opposed to the original one. Okay? All right, so let's look at these 3 examples and see if we can look at all the differences between the two. Our first one on the top left is your translation. Okay, please call it a translation and not a slide. We're now in high school. So you can translate a shape either to the right or to the left. You can translate a shape up or down. You can translate a shape right and then up, or left and then down, or vice versa. Rotations, those are the hardest ones to do graphically. We got to do a little bit of thinking process there. So rotating something around a point, usually we rotate around the origin. And then reflections, I think those are probably the easiest ones to graph because we're used to plotting out reflections of 2 things. Okay? So translation, rotation, reflection. Those are the 3 transformations that do not change the shape of the original image. It stays the same. So, up here, what transformation is being demonstrated in the picture between the 3? It is a translation. Specifically, what's happening from the first triangle to its image. It's going to the right and then down, right? Because remember, the prime symbols means that's the image. This is the original. This is the image. Specifically, it's going over how many units to the right? I think it's
6.
1, 2, 3, 4, 5, 6 units to the right, and it's going down 2. If you well, A would be the same thing, right? 1, 2, 3, 4, 5, 6, down 1, 2. C would be the same thing too. All right, second one, what do we have going on? That would be a reflection, correct? Reflection. And then the last one is an example of a rotation. Good. All right. So now let's get to the good stuff. The actual coordinate points. So we have what's called, skipping that, I don't know why I have that in there. We have a notation for when we're talking about the coordinate points on a coordinate plane. Now, if I gave you a point, x, y, like 1, 2, you should hopefully be able to plot that point. I hope. If you didn't, I don't know why you're in this class, but hopefully you did. So when we start with all of our transformations, we're starting with an original point. So that's why all of these start with x, y. We're starting with the original ordered pair. And then we use an arrow to depict the transformation, what's happening. So if we were to have a translation, and you get used to this notation, you're going to have some number, we're using A to represent some number, that's going to be added to your x. That some number could be a negative number, which would really be the same as subtracting it from your x. And you could have the same thing happening to your y. You could have some number b being added to your y. Okay? For a translation, if you think about your x and your y coordinate, or your axes, sorry, Your x is the horizontal one, right? So anything that's happening to your x is your left or right movement. Anything that's happening to your y is your up or down movement. I don't know if you want to make note of that. That's a little cheat sheet. So if you were to add something to your x, that would move it to the right. If you were to subtract something from your x, that would move it to the left. If you were to add something to your y, that would shift everything up. If you were to subtract something from your y, that would shift everything down. Then we've got our reflections. If you were to reflect something over the x-axis, you take your y coordinate and multiply it by a -1, or just change the sign. So if your y was positive, it would become negative. If your y was negative, then it would become positive. And if you were to reflect over the y-axis, your x's would change. So if your x was positive, it would become negative. If your x was negative, it would become positive. Those you don't really have to worry about so much because everyone can kind of visually see where a reflection would be on the coordinate plane. All right, so we're going to do 4 different transformations on the back. The first 3 all deal with the same triangle, so you're going to get good at plotting that triangle. So let's all plot the point A at -4, +3. So find that point. Mark it with an A. B is at -2, 4. Mark it with a B. Put it in the oven for baby and me. Sorry, I got patty cake in my brain. -1, 1. Mark it C. And then connect because we're making it into a triangle.
Straight edge?
No. Unless you really want to.
I don't want to.
If you need to do that so that you can survive for the rest of the day, then go for it.
If you don't want it, then you have to.
All right, so look at what we're asked to do. It says, what would the coordinates of the image be if it was translated +5, -2? So you've got 2 options. If you're good at just looking at it and saying, okay, well, +5 means I'm going to shift it to the right 5 units, and my -2 means I'm going to go down 2, then you literally can just go 1, 2, 3, 4, 5, down 1, 2, put your new point. Bam. Or you go 1, 2, 3, 4, 5, down 1, 2, put your point. Bam. And then do the same thing for C. If you like to see what you're doing, sometimes I like to do this, or if it's just asking for the coordinates and not for you to sketch the image, let's show what's happening. So my A point is -4, 3, and it's telling me to add 5 to my x, subtract 2 from my y. So the new image of A, well, -4 + 5 is 1. 3 plus -2 is 1. So the image of A becomes 1, 1. Point B is -2, 4. The image of B would become -2 + 5 is 3. 4 and a -2 makes 2. And if we do the same thing for C, which is -1, 1.
What did you add?
The same thing. So I'm adding 5, subtracting 2 for everything. So I can rewrite that down for all of it. It helps you. So -5, +5 -2. So then C, -1 + 5 would go to a 4. 1 and a -2 makes -1. So if it just asked for the coordinates, we could do this, because here would be my coordinates. And let's go ahead and sketch it. Excuse me. So if we plot those points, 1, 1 is right about here. I'm going to mark it with an A prime. Ethan?
I hate to do this to you, but do you mind going through the steps again?
So all I'm doing is I'm taking each of my ordered pairs, and then it's telling me to add 5 to all of my x's. So each of my x's, I'm adding a 5 to it to get this number. And then it's telling me to subtract 2's from all my y's, okay? Not a problem. Make sure on your test and on your midterm, when you do this, you need to make sure you mark your image with prime signs or you will get points off. So you have to specify which one is the image. So 1, 1 is there, 3, 2 is here, and 4, -1 is here. So that's going to be a C prime. So if you check it, did your A shift to the right 5 and down 2? 1, 2, 3, 4, 5, down 2. Yeah. Did your B shift to the right? 1, 2, 3, 4, 5, down 2. Yeah. Did your C do it? 1, 2, 3, 4, 5, down 2. Yes. Okay. Translation. We're good there. All right. In the next coordinate plane, please create the same triangle. So we're recreating the same red triangle in the second coordinate plane there for you. Getting rid of this one. So again, we're plotting negative 4, 3. Mark it A. Negative 2, 4. Mark it B. Negative 1, 1. Mark it C. Connect into a triangle. Alright, so this time we're reflecting it over the y-axis. Now reflections I think are the easiest just to go and do it. Jack?
Are we doing both of them or just like the first one? Like,
Just this first one. So back to the original, we're just going to reflect it.
alright.
So now I'm going to take this whole triangle and reflect it over the y-axis. So right now we're in quadrant 2. Remember how we label quadrants? 1, 2, 3, 4. So right now we're in quadrant 2. If I were to reflect it over the y-axis, that would put me into quadrant 1. Me personally, I would just look at this and say, okay, well C is 1 unit away from the y-axis. So if I stay on the same line and go 1 unit away in the right direction, that's where my image of C would fall. B is 2 units away, so if I stay on the same line and go 2 units away on the right direction, that's where my B would go. And then A is 1, 2, 3, 4, so 1, 2, 3, 4 over, keeping it lined up, so A prime, and then connect. If we were to list the actual coordinates, so A started out as negative 4, 3. When I reflect it over the y, your x changes sign, so it becomes a positive 4. 3 stays a 3. My B is negative 2, 4. If you're reflecting over the y, then the x changes signs. So the image of B would be positive 2. The 4 would stay a 4. And then your C is negative 1, 1. Reflecting over the y means your x changes sign. So my negative 1 will go to a positive 1. And that positive 1 would stay a positive 1. We'll get you to the quadrants, or the coordinates. Okay, so we're good with translations and we're good with reflections. You're going to reflect it over the x-axis, so we just shift this whole thing down here, right? So C would fall here, B would be down here, A would be here, and so forth. All right, now rotations is where it gets tricky. So pay very close attention to the rotations. All right, so in the third quadrant, let's recreate that same triangle. So negative 4, 3, point A, negative 2, 4, point B, negative 1, 1, point C. There we have it. All right, so we're going to rotate this triangle 90 degrees clockwise. Now remember, quadrant 1 is the upper right. So we got quadrant 1, quadrant 2, quadrant 3, quadrant 4. I guess I should put those down lower so I'm not in there. So 1, 2, 3, and then 4. Okay. Right now, in quadrant 2, what is the sign of all of the x coordinates? Is it positive or is it negative? Negative. It's negative. And what's the sign of all the y coordinates? Positive. Good. Hello? Hi. Yes. Can it be in 5 minutes? Sure. Okay. Bye. Okay, it's just Mrs. LaBelle. You can go see her when we're done with notes. Okay, so right now in quadrant 2, I'm at a negative x and a positive y. If I were to go 90 degrees clockwise, am I going to move to the right or to the left? So I'm going to end up in quadrant 1. What are the signs of my x and y in quadrant 1? Positive. They're both positive, right? Here I'm positive, here I'm positive. So, whenever you do a 90-degree rotation, you interchange the x and the y. So let's see this happening. So A right now is the point -4, 3. If I was to do just one 90-degree rotation, I'm going to physically change the 3 and the 4 so that the 3 goes into the x spot and the 4 goes into the y spot. And then this is where the trick comes in. I'm going to take on the signs of the quadrant that it would fall into. Okay, so since I'm going to quadrant 1, I'm going to flip-flop the 3 and the 4. And since it's falling to quadrant 1, it's going to be positive, positive. If I were to go counterclockwise, meaning I would end up in quadrant 3, what are the signs of quadrant 3? The x is negative and the y is negative. So if I were to go counterclockwise, then it would be a -3 and a -4. So we're going to quadrant 1, so it's going to be positive, positive. So for my B is -2, 4. So B prime, so I'm flip-flopping the 2 and the 4. And then I'm going to take on the sign of the quadrant that I'm going to fall in, which is going to be positive, positive. C is -1, 1. So C prime, well, 1 and 1 is going to stay 1 and 1 even when you interchange it. But since I'm going to quadrant 1, it's going to go positive, positive. So let's see what those look like. Go ahead and plot those on the graph. So 3, 4 gets me my A prime. 4, 2 gets me my B prime. 1, 1 gets me C prime. So there is my rotation. For fun, let's rotate it another 90 degrees, which means it's technically how many degrees from the original?
180.
180. So if I were to go 180 degrees, wouldn't these then flip back to the original order? Ethan, question?
At that point, can you just do it as like a reflection? Because it's kind of like.
Well, it's not going to be technically a
Well, you
reflection
already have it
because,
in the other quadrant, so maybe you just.
yeah. Well, let's see what it looks like first, then we'll see if that works. So if I rotate back to the 4, 3 and take on the signs, so quadrant 4, what are my signs? X is positive, Y is negative. Okay, so if I go back again, so I'm going to get rid of this so I can write it out. So I'm going back to 4, 3, but now I'm going to a positive and negative, so it's going to be a positive 4 and a negative 3. So if I do another 90 degree here, it's going to go back to 2, 4. It's going to go to a positive, negative. So positive 2, negative 4. And then my C, well, 1, 1 doesn't really change, but now it's going to be positive and then a negative 1. So let's see what that looks like. I'm going to do that in green. So 4, negative 3 is here. I'm going to give that an A double prime. 2, negative 4 is here, so B double prime, and then 1, negative 1, C double prime. So let's see if Ethan's way would work. So if you reflected it, it's kind of like you're reflecting over the line y equals x, right? So over 1, does the B work that way? 2, I guess kind of, as long as you know that you're doing it kind of opposite of each other. And then if we were to rotate it again, which we won't, we would flip these all over again, and they would take on the sign of everything being negative. Okay? So let's see if you can do the last one. Let's go ahead and get that one set up. Yep. And go ahead and start plotting the last triangle. It's different, a little bit different than what we've been doing, because now each point's falling in a different quadrant. Good stuff right there. Oh, we're not using the same triangle. The coordinates are changing for the last one.
Oh, they are?
Yeah, on purpose.
I drew them earlier in advance.
That's good skills of trying to get ahead, but then we need to make sure we're reading out directions. Yeah. Good? Okay. All right, so for the last one, our A is now at 4, 3, so positive 4, positive 3. Our B is at negative 2, 4, that's in the same spot. And then our C is at negative 1, negative 1. So there's our triangle. Okay, so point A is at 4, 3. Right now it's in quadrant 1. If I were to rotate it 180 degrees, it doesn't really matter which direction it would go into, which quadrant would it go into? It would go down to quadrant 3, right?
Why is it in 1?
Positive 4 or positive 3. I changed the...
No, I mean...
So it goes 1, 2, 3, 4. So right now A is in 1. Right? If we were going 90 degrees, it would do a 3, 4, carry the sign. 180 degrees takes us back to the 4, 3. So my 4, 3s are going to stay the same. But what's the sign of everything in quadrant 3? Negative. So it's going to be negative 4, negative 3. Point B is negative 2, 4. So B prime. All right, so negative 2, 4. We're in quadrant 2. So 180 degrees is going to take us diagonally over to quadrant 4. The 2 and the 4 are going to stay the same because it's 180 degrees. But what are going to be the signs? In quadrant 4, it's positive, negative. So your 4 is going to become a negative. Point C, negative 1, negative 1, is in quadrant 3. Take it to quadrant 1. So it's going to be positive 1, positive 1. So let's see what that looks like. So negative 4, negative 3, A prime, 2, negative 4, B prime, 1, 1, C prime. So there it is. Rotated 180 degrees. Questions?